Good afternoon, everyone. We'll start our today's session. So we'll see one example over manual part programming of simple milling. So you can see over here in this diagram, the tool is so milling operation is there, ready? And it moves from A to B, then C, then D, and there is again a tool is there of ES40. Then it moves from E to F, F G, again a control, and again the linear up and ends is then come back to its original position, that is A. And here SP means the starting position of the tool is given, that is 200, 150. I will write that because it's not highlighting that email. 200, 150, and 50. So this relates to the position of the coordinates. This is for X coordinate, this is for Y coordinate, and this is for Z coordinate. So the starting position of the tool you have to consider for this particular program is X is 200, Y is 150, 50. And in this problem, they have given you feed rates. So two feed rates are given. Feed rates are given. One is the cutting speed feed rate of 240 mm per minute, 240, and this is your H. This is your V, and H is the 480 mm per minute is given, and RPM is given is 600 RPM. Yes, is so spindle speed, we can say spindle speed is yes equal to 600 RPM is given in the problem. So these two feed rates is this 240 is for the approaching feed rate, and this is the cutting of the feed rate. Means when it gets first approach into the depth of the depth given is 12 mm. So this is the 12 mm depth. Okay, so in Z direction. So for that depth of first depth, it will take 240 mm per minute feed rate, and after that it will take 480 mm per minute. Okay, so considering this as a Siemens programming. So for Siemens programming, we'll start with percentage. Suppose ABC will be the name of this program, and 1, 2, 3 the name of this particular program. Then starting with the first, we have to start with the N. Write first the block, and then I will explain each and every codes. So G00, 00, G90, G71, G17, G94. Okay, and after this end of block. Okay, so what is this N05? This is the serial number of your block. You can take N10 or N, but N05 means you can edit this program up to 5 times. Okay, N10 means you can edit, you can input or add the blocks up to 10. Okay, then next one, this G00 is nothing but rapid traverse. It will take rapid traverse, and G90 we are considering as an absolute coordinate system. It's an absolute coordinate system. G71 is for the metric unit. Suppose if it is a Fanuc control, we will start with the program with 1, 2, 3. Okay, and then instead of this G71, we will use G21 metric unit. Okay, so this is the difference between the Fanuc control machine and the Siemens control machine. So we are considering as a Siemens control, because in our college we have Siemens control CNC machines are there. Okay, so GC1, then G17, So in examination also you can consider any control, that is the Pano control or segment control. So that doesn't matter. G17 is nothing but we are considering this work in XY plane. So you can see over here. So this is the Z axis, and this is your x-axis. Okay, so this is the top view, and this is the front view of your workpiece, and you have to mill over the periphery of this profile. Okay, you have to mill periphery of the profile, and they have only given you in this problem to that is the end milling. They do not include this drilling operation. Okay. So next one, G71, 17 is for XY plane. G94 is for that feed rate is in mm per minute. Feed rate is in mm per minute. Okay. So when I explain any part programming, you have to take the if you have to by heart that codes, or you can refer that codes as I explained in the previous lecture, so that you can get logic of the coding. Okay. Then after this, I will use next series, that is N10. So the gap between the two series is 5. So I can edit up to 5. The N10 X X 200 X 200 Y 150 and Z 50. So this is the initial point which is mentioned in this. That is the starting point of your tool is 200 X, 150 is your Y, and 50 is your 50 is your Z. Okay, and you can mention the tools also in this program line, or you can again take N15, and you can use this M06 M06 P01 P01 S 600 S 600. Okay. Okay. So X 600. So it means that first we have a rapid transfer in use, that is a G00, and G90 is we are considering this point, this O point is the origin. Means this point is your origin point. Okay, so this from here you have to take the dimension. Okay, all the dimension of X, Y, and Z. Okay, then G71 we have used the metric unit. 17, that is X per plane. G94 is for mm per minute. Then G004 is again continue over here. So it rapidly traverses to the inner starting point, that is X200, then Y150 and Z50. Then after that starting point, this tool will be changed. The tool will be changed, and it will select the tool that is given in this problem. Is the diameter of the tool given is 20 diameter, 20 diameter tool is there. So this tool number is in the magazine. It is in tool number 1. Okay, and the speed is 600, and you have to start the spindle. You have to take 600, and you have to start the spindle. So for starting the spindle, you after this selection you have to use suppose N20, next is N20, G00 is continued. So I will start M03, and you can start also M05. Sorry, M08. M08 for Poland on. So what I have done, I have moved that tool. First, I have moved that tool to X and Z coordinate, right? And then I changed the tool to T01, and I have set the spindle speed, that is 600 RPM. Then I have started the spindle M03. Then I have started the coolant. Okay. Next, N25. N25. Now I have to move that to just above this surface of here. I have to move this just above this here. Here I will move the tool. Okay, just above the surface of this. So for that, for that purpose, I will use G00 is again is started. So I will use first cutter radius compensation towards left. So it is in left. If it is pocket, then I use G42. Okay. So G42, G00 is don't require. We don't require that because it is not changed. Or otherwise we can write also G00, G00, X0 and Y0, X0 and Y0. So now the tool will move from, suppose it is over here, okay, 200, 150 and 50, and then it moves towards this origin point, and it should be above 50 mm. It is now just above this tool. The distance between the tool is 50 mm from this surface. Suppose it is a PMO, okay, 50 mm distance is there. Then I will move down this tool N30 next series, and I will use then Z2. Okay, now it is just above 2 mm from the surface. Now I will give the cutting block, that is M35. I will use for cutting. You have to use G01. Okay. Now it gets approach up to which depth? 12 mm depth. So Z minus 12. Z minus 12 you have to take, and the approaching speed they have given is F equal to 240. F equal to 240. So now this tool moves over here, next position over here. Okay. So now it is over here. That is at A point. Okay. And the tool has taken the depth of 12 mm. Depth of 12 mm with a speed of 240. Okay. Next, I have to move the tool from A to B. A to B. A to B distance is 80. A to B distance is 80. So next programming line will be N40. N40. G01 is continued, so don't require to write again and this G01. So you have to change the direction in X direction. Now we have to change the direction in X. So X80. 80. So this distance, it will now move from A to B, X80, and for this they have given you the feed rate of, what is they have given, 480. 480. Okay. Then after this, there is this slant is there. Okay, this slant is there, that is from B to C. This slant is there. Okay. So at time there is two moment of the tool, that is in X direction as well as in Y direction, and the tool is approaching towards point C. The tool is approaching towards point C. Okay. Now the tool is here. You can say first here spindle start. Okay. Then here initial position, reference position taken. Then here approach and first cutting is done to the depth of 12 mm. Then here this linear cutting is done. The next one, this for this B to C, that is from A to B, is covered over here. Now B to C. For B to C, N45. Okay, N45. I will take X. Total distance is I have to find out that this 80 plus this radius 40. 80 plus 40. So it's equal to 120. Okay, so you can see here over here also 60 plus 60, 140, 120. Okay, so this X distance is 140. Then Y distance is Y distance they have given. Okay, they have given total distance 120 from the center. Oh, so it you can see over here. This 120 is from this center to this end, and again they have given from this center to this 60. So it is equal to 60. Y is 60. Okay. So you have to take that x 120 and y 60. X 120 and y 60. Now the cutter moves from B to C. B to C, in which two axes are working. Two axes are working. In this case, only one axis is working. In this also, one axis is working. So it moves from B to C. Okay. The examination don't require to write this. I'll just writing for your understanding. Next, now C to D. Now the cutter moves from C to D, from this position to D position. Again, there is a linear and only Y direction approach is there. So N50. So this 60 plus 60 is equal to 120. So Y 120. Now the cutter moves from end of block. So semicolon is used for end of block, or you can use, instead of this semicolon, you can use this star mark. Okay. So now the cutter moves from C to D. Now next, D to E. D to E is a contour. Is a radius is there. Okay. So at this time, again, it will work in two axis, but with radius. So there should be a circular interpolation. So from this A to B and C to D is a linear interpolation, but from D to E it is a circular interpolation. So you have to write down the code, and it is in counterclockwise direction. It is not in clockwise direction. It is in counterclockwise direction. So which code is used for that is G03. So this is used for circular interpolation in counterclockwise. And then you have to give the coordinates of this E point. Coordinates of this E point. So how much it is? 120 plus this radius 40 is 160. Y will be 160, and x will be 80. X will be 80. Okay. So this is 120 plus this r radius r40, so it's equal to 160. And this, for this you can see over here, A to B it is 80, and this center is also matching, so it is 80. Okay. So G03 x 80, y 160. Okay. R radius is 40. Okay. Radius is 40. So now it moves from D to E. At this block, the cutter will move from D to E. The next one, again there is a linear E to F. There is a linear interpolation. So N60 G01 linear interpolation. G01. Yep. How much distance is that? Okay. 40, 80. Okay, 40. X is G01, X 40. X 40. Okay. So now it moves from E to F. E to F. Now it moves from E to F. Okay. Then next, N65. Now again this circular interpolation is there. Again it is in counterclockwise direction. So again to take G03. Okay. And now we have to check for the coordinates. So x will be 0. Y will be at 120. X will be 0 and y will be at 120. And radius is again R40. 40. This radius is R40. Okay, so end of block. Then it moves from this F to G. To G. Okay, F to G. Now the cutter moves from F to G at this end of block. Then N70. Again, there is a linear interpolation is there, and the distance between G to A. Now the cutter should move from G to A. G to A. So distance is X is remains 0 only, and Y also becomes 0. Okay, so X 0. So don't require to write that X again. G0 1, Y 0. End of block. So now this cutter will move from G to A. G to A. Now after completion of this milling, again you have to move your cutter in upward direction, because you have completed a milling of this periphery of this profile. So for that, N75 G00. There is no cutting, so I am using G00 and Z2. The cutter will move just above this A point, about 2 mm from the rest of this plate or this profile. Okay, G0 Z2. Now you have to bring back that. So again, above surface. Okay, over here. Now again you have to bring back to the starting position. Bring back to the starting position. N80. Before that, you have to cancel your radius compensation. So G40 is code is used for cutter radius compensation cancel. Radius compensation cancel. Cancelling of compensation. Now you have to use 85 G00 F200, that's the starting point again, Y150 Z50. Okay, so this comes back to its original starting position. Now you have to off whichever you have started. What you have started, that is you have started a C. So this at M03, you have to stop that. Okay, and then you have to stop the coolant of this M08. So for that, N90, you have to stop that. M05 and M09. So for M05 means a spindle is stopped. Okay, M03 is a spindle start clockwise, M04 to counterclockwise. Okay, so M05 is to stop the spindle, M09 to stop the coolant. And again, if you require this code, is not required, but you can write down this again. 95 I will say G28 for the home position of your tool. You can write over here, so G28 over here, and then you don't require to write this. Okay, X200, and so it will move back to its homing position of that machine. Okay, but in animation you can write this G00 X200, and you don't require this coding. Okay, so N95 is M02 is okay if there is no further operation or further component is there for machining, and if you again want same component to be machined again, then you have to use M30. Okay, so at this time program will stop and reset. Program stop and it gets reset. Okay, so this will complete your part programming. I repeat once again how we have done. So in this problem, they have given you the feed rate and the spindle speed, that is 600 RPM, and two feed rates are given, that is the approaching feed rate and the cutting feed rate. Okay, so and diameter of the cutter, end milling cutter is 20 mm diameter is given. Then they have given you the spin position, that is X200, 150 and 50. So started, we are consider this as a Siemens programming. So we use this percentage ABC 1 to 3 is the name of that program. Then N0, we have given the initial question. Okay, so if you want to save this program for future, then you can use G54 here, G54. So the homing position of this will take directly for the further operation. It comes after a week or after a month or yearly. So G54, if you use this G54, it will take that workpiece made 0. Okay, so no offsetting is required if you have done previously this program. Okay, so G00 you have given absolute coordinate system, you have given metric unit, you are working in metric unit, XY plane is given, G94 is mm per minute. If the in question you ask you find 3 revolution per minute is there, then instead of this 94 you have to use 95. Okay, if the feed rate given is in find revolution per minute. Okay, then you have specify the initial position of the starting position of the tool over here block, and then M06 you have change the tool and you have set the tool number to 1, and you have set the spindle speed to 600. Then you have started the spindle and started the coolant. Then you have given the cutter radius compensation over here, and you have set the X and Y 0. Okay, then you have just moved your tool about 2 mm from the surface over here. Then next you have cut from A to B. You have first approach the tool with a feed rate of 240 mm per minute. Then you have move the tool from A to B. Then after that A to B. Then after that there is simultaneously X and Y motion is there, because the linear interpolation, it is in slant or in angle. So you have taken X and Y over here, and B and C is completed. Then after that C and D is also linear. Then G03, because it is a counterclockwise circular interpolation, and radius is 40. And then again linear is there. Again there is a radius, again counterclockwise over here. Then you have completed this cutting to this last position, that is from G to A, and then after that again you remove your tool just about 2 mm over here from the surface of the workpiece. Then you have cancelled the cutter radius composition as you started this G42. If you not write this G40 here, it will show an error in the program. Then G00, again you have moved to the initial position or the starting position of tool. Then whatever you have started, that is spindle started, you have stopped the spindle, and coolant also stopped over here. And M30 is the program stop and reset. So in this way, you can write the manual part programming in the examination. So this is a simple example of an So any doubt in this, you can ask me. If there is any doubt in this, or otherwise we will approach to our next problem. Any doubt in this? Just we have while taking this session, and when I'm taking this session, you have to use your notebooks simultaneously, or you can refer the codes so that you can verify how the programming is done and how the cutter approaching to the profile, so that you can get the concept of this. Okay. So any question regarding this problem? Because it is very much hard to understand in first instance. Hello.
Sir, in examination, we need to learn these all codes or remember these all codes, or we have any handbook
No,
for that?
no. You have to remember these codes. You can remember in a bunch. How to remember? I will also tell you how to remember these codes. You can see over here. So this G0, if I use this, okay. How to remember? I will show you. Okay. Okay. So this is a bunch. Okay. So G01 to 2. This is one. So this 0, 1, 2, 3 is only for the linear, circular, and moment of the tools, that is in linear way or circular way, or it is just with a speed. Then G17, 19, 20 is for the plane selection. You can remember it. Then marionette, there is another set. Okay, compensation set is there. Okay, this is one set. Then next, you can remember this is one of 5 codes. Okay, then you can remember this scan cycle set. Okay, and these 2 sets are there, 90 and 91. These 2 codes are there, and you can remember this 94 and 95. For G codes only, you can count this 1, 2, 3, 4, this 5, 9, this 6, 15, 15. 25 codes are enough to remember, but you can remember this code just by how it gets operated, so that that must be lifetime you can remember this code. Okay, I have remembered this code at the time of when I am of your age, at the time of college, and still I have remember all these codes till now. Okay, and refer that codes back, because I am thinking how the cutter is approaching, and I am relating that code with that approach, so that I can remember easily. Okay, so coming back to the problems. Okay, so this is a simple milling. So in examination, they will ask you milling as well as turning also. Okay, part programming of this. Then this is a set of operations they can ask you for 10 to 12 marks. Uh, so in this, means in examination they will not ask you this much depth. There are 1, 2, 3, 4, 5. 5 operations are there, sequence of operations. So they will ask you hardly up to 2 to 3 operations. Okay, but the time of learning we can see all these 5 types in one, or 5 operation sequence. Okay, so first we see what is exactly operation sequence is. So you can see a plate is there, and over that plate another profile is there. So in this operation sequence, in this step form, you can see there's first operation they have given you is a center drill. 2 holes are there, so this hole and this hole will be there. Okay, these 2 holes there. So first they have told you to center the drill first with the tool number T01, and your spindle speed should be 5000 rpm, and feed rate should be 500 mm per minute. They have told you. Okay, then after that they have to in the next sequence they have given you another tool, that is T02, that is of diameter 10 diameter. Okay, 10 diameter tool is there, that is of material HSS drill. Okay, and you have to take the spindle speed as 1000 rpm, and mm per minute feed rate is 100. Okay, and you have to complete this 1 number hole and 2 number hole, sorry, 1 number hole with the depth of up to depth it is given 8 mm, 8 mm depth. So in case of drilling operations, you have to take breakthrough distance also, because the tool because the tools are in this way. Suppose I will draw one diagram over here. Suppose this is the workpiece, and you have to drill this hole. Then the tool shape is in this way. Okay, in this conical type tool is there. Okay, so if you give it suppose this is depth of 10 mm. Okay, and you have to machine this up to 8 mm, as this in this case for this tool, for this hole. So if I give only z equal to -8 mm, Okay, minus 8 mm. Then this will move up to this point of the tool will reach to this up to the depth of 8 mm, up to the depth of 8 mm. Okay, so depth of this. So it will create in the whole create in the shape in the forming shape of this tool. So for that you have to take a breakthrough distance. So you have to take 2 mm more, 2 mm or 3 mm more as per this uh, depth. Okay, so so that the depth of the hole should reach to the this 8 mm or any value they have given. Okay, so that is called as breakthrough distance. You have to consider if it is given 8 mm depth, you have to take minus 10 instead of 8 mm, and you have to give the value. In this case, r you have to give a radius. It is not related to radius, it is a breakthrough distance, are related to breakthrough distance. We will see that at the time of programming. Okay, then next again a hole again, that is a hole. The second one, this is a through hole, is given, that is also 10 diameter, and you have to use the same over here P02 with the same speed and feed rate. Okay, next, milling operation they have included. Milling operation, profile milling this. So you have to move this in this way, the profile milling. Okay. Then next one, slot. So this center slot is there. So that is of white and 3 mm depth slot there. You have to use another tool, that is T04. With this 320 is the cutting cuttings of the tool, and is 160 is the feed rate for means when first approach done up to the depth, it will use 160 mm per minute, and after that it will take 320 okay mm per minute. In the same for this slot also, for profile milling and slot milling. Okay, we'll start programming this first. Again, as you practice this part programming, you can relate this concept very easily. Okay, so first again same, starting we are considering this Siemens control M231. Okay, in this way, and starting with M05 G00. Again, these starting ports are same. Okay, G90. So I using the series, first series of the block is that the tool should move in a rapid way with considering the absolute coordinate system. Then it should consider the units in metric. Then it should consider in XY plane G17, in G94, because in the question they have asked you the feed rate is given in mm per minute, so G94. Then after this you can use any code for saving this workspace 0. I will use G55. Okay. Then next N10, N10. I will this problem they have given you the starting point 200, 150, and 50, similar to the previous problem. So again you have to use here X 200, X 200, Y 150, Y 150, and Z 50, Z50. Okay. Now, after mentioning this, you have to move your tool to this origin position. Origin on the initial position, or you can say origin of the workpiece, where all the X, Y, and Z is equal to 0. Okay. X, Y, and Z are equal to 0 at this point. Okay. So for that, N15, you have to take, and X0, Y0, and Z2. So I have moved that tool from this initial starting position to this origin position, and just above 2 mm from this surface. 2 mm above. So and the diameter of this profile, or this first is we have to complete the central drill. So it is of a diameter that is A2 type. So there is a this is a standard central drill. Okay, this is a standard central drill, so it doesn't require that. And you have to specify, after this you have to specify the tool number T01 M06 tool chain T01, and the spindle speed they have given you is 5000. 5000, yes, 5000. Okay, then you can write the feed rate here also. Here also you can write feed, that is of 500. Okay, so you have moved your tool to this initial position, that is this origin position, x0, y0 and z2, and you change the tool to just you have to first, this should be n, I will use n25. I will use this n25. So at the time of programming also, it will take n10 first, then n20, then it will move to the n25, because first it should check tool, then it should move to the this origin position. By mistake, I have first move that. So you can edit in this way also. Okay, so n10, then it will move to n20, then it will move to n25. Okay, and it will move to this origin position. After this, I have to make the center tap over here, this first hole as well as in the second hole. Center tap should be there. Okay, so for that you have to write G0. First you have to move this tool to this position, center of this hole. So for that, n, I will use n30, x35 and y35, x35 and y35. I will not use z2 because it is moving just about the 2 mm from this surface. Then this blank is of thickness. Now the blank is of thickness 15 mm. The blank is of thickness 15 mm. It is not, I will tell you, it is not profile, meaning is not. Just a simple rectangle is there, 120 by 120. Okay, still it is a 120 by 120 rectangle. So it is just move from this origin position to this position. Okay, center of the hole position, and just about 2 mm, because I have given Z2, not given yet the depth. Okay, so X35, Y35. Okay, then you have to start the spindle. You have to start spindle and coolant M35, M03 will start in clockwise, and M08 will start the coolant. Okay, next N40. Now we have to make the central drill. Okay, you have to make the central drill. Okay, so central drill at this position. So for that, I will use G01 Z. I will take randomly Z -5. Okay, Z -5 and R2. Okay, so I will use Z -5 and R2. You can take Z -3, 5 or 6, but not more than 8. Okay, because it is just a central drill. Okay, and you can give a feed rate of that is already given, that is 500 mm per minute. Okay, so it makes this center tap over here. center drill over here. Now we have to move this tool from this position to this position again. Again, you have to remove this tool from that depth, that is Z minus 2. So again, we use N45 G00 Z2. Here center drill is done. Center drill for hole number 1. And now this will retract the tool. Tool is retracted over here. Okay. Now we have to move from this first position to the second position of the hole. So it is of distance, not clearly visible. Okay. So this is 15. No, so for first I have taken x35 and y35, that is 15 plus 20, and this also 15 plus this 20. So it is x25 and y25. Okay. Then next for this, you can see over here it is a 15 plus 20 over here, 15 plus 20, and then 50, then 50. Okay, so you can say 35 plus this 50, so it should be equal to 85, and we will check 85, sorry, x direction. So y is 85. Now we have to check the x, that is 50 plus this 20, again this center. Okay, this is center 60 plus this from over, it is 60. Okay, it's given dimension 15, 50. Okay, 15 plus this 20. Okay, 15 plus this 20. So it is also over 35. You have to minus this distance. So this is 20 plus 15. So 35 minus 120, it's equal to 85. Okay. So write down that coordinate N50. Now the tool will move from this retracting position to that center of the second hole. So for that, write down x85, y85. So now the tool move at the center of second drill number or hole number 2. Okay. Now it will again drill the hole or tap the hole. So for N55 G01 and Z minus 5 R2. Okay, again it has created the drill over here. Center drill completed. Again you have to retract this N60 G00 Z2. Okay, Z2. So again this is a retraction position of the tool. Retract. Okay. Then next, we have completed this first operation. Then next one is a drilling operation. So there are only one tool is used for drilling of both, but the depth is different for hole number 1 and hole number 2 is a through hole is there. Okay, and same tool is used. So for that, first you have to call the tool change in the block. So N65 M06 P02. Okay. Before this, you can include the homing position to change this tool. So I will use 61 G00 and G28, so that it will move first to its homing position, and now it will change the tool with the speed of they have given you the speed yes 1000. And again, you have to stop the spindle also before changing this. So I will use N62 M05, so that the spindle should be stopped first. Then now it will take this tool change call, and it will change the tool to T02 with the spindle speed of 100. Now again I have to start after this change, use N66. Suppose N66, I will use the spindle start. Coolant is on, so don't require to off the coolant. So M03, again the spindle start. Okay, now it starts with the tool number 2. It will start with the tool number 2. Now I have to make the drill. So today we will complete only this up to this second and the third operation, and then we'll continue in the next lecture this fourth and fifth operation, that is a profile milling, and we will refresh first these three operation in the next lecture, and then we'll approach towards this profile milling and slot mill. So I will complete this first, the depth hole and a through hole. So first, for depth hole, I have to bring again the tool to the 70. I will use 70, N70, G00, X0, Y0, Z2. Okay, now it just again comes to its starting position over here. Okay, then N75, I have to move to the coordinates. G00 don't require. Again, X35, and Y35, X35 and Y35, and next N80, you have to take the depth G01 up to the depth is here equal to -10. That is, I have taken 2 mm extra, for the breakthrough distance, and R2 is taken. Okay, R2 is taken. So that is the breakthrough distance is 2 mm. Okay. Next, again I will bring back the tool 85, G00, Z2. Now again it gets retracted from the surface, and now N90, it will move. You have to move the tool from this hole number 1 position to hole number 2 position. That is at we'll refer that coordinates X85 and Y85. Okay, to 85 and Y85, and now we have to give the tool to the drilling. So it will G01, Z. It is a through hole, so you have to take depth is the total 15 is there. So you have to take more than that. So I will take my hello. So who is there? Mute your mic, please. So coming back to this operation. Okay, G01 Z minus T. So this -20 depends upon the bed where it is. Okay, so if the bed is there, so it will drill the bed also. So you have to consider the bed depth, how distance it is. So I will take it is the total is 15, so I will take 18. So again R2, so I will take R3, 3 mm more to the exact depth of the second hole, through hole. I will take 3 mm more, R3. So this completes. Again, you have to bring back the tool and red. G00Z2, and then you have to change the tool. So for again you have to repeat this N 105 G00 G28, so it will come to its homing position. Then you have to stop the machine spindles, so M05. Then you have to call the next. So here you have to call the next tool, that is tool number 3 for profile in the next session. So thank you for listening. I will refresh in the next session also from the start. Okay. So I will first download your attendance. Okay. So any questions regarding today's session? You can ask me now, or you can text me in this, or post a question over this meeting or up meeting in the team. Okay. So any questions? Okay. So next time you will you have to write with me the programming, and you have to refer the codes so that you can easily get learned, or no need for any by head of this code. याद रखने की कोई जरूरत नहीं है इसकी. अगर आप मेरे साथ करते रहोगे और देखते देखते भी आप कोडिंग करोगे, if you simultaneously work with me, then there is no need to by heart that codes. Okay. So just you have to know how the sequence of operations and for what operation which only that you have to remember it. So thank you for today's session. I will stop my session. Any questions? I think there is no question. Okay, I'll stop the recording.